Hi, everybody. Hello. Hi, it looks like I have Amarani, Zitlali, Fabrelia, Carly, and Stefania. Good to see you guys. All right. Oh, give me 1 second.
I'm here just putting. That's why they can't see you. Getting my son's clothes on. I had to give him a bath. Come here. Come on. Come here, please. Thank you. Come here. Come on. Come on. Come on. Come on. Sit down. Stand up. Stop. Stop.
All right, everybody, it's 5:30. Let's go ahead and get started. I'm going to go ahead and share my screen. Give me a second to do that.
Here, put the same room. Bye.
All right, can we see that okay? Awesome. All right, so obviously we're going to go ahead and start off with this chapter, which is chapter 6. In chapter 6, we talk about general anatomy and physiology. So that's basically the anatomy and physiology of the whole body in one chapter, which is a lot of information to go over in one chapter. So just bear with me. These slides are a little bit longer than usual. But what we're going to actually talk about in this chapter are the different body planes, the directions. We're talking about the directions of the body cavities, and then all the structure and functions of a cell. Okay, so we'll talk about the functions and structure of the muscular system, the nervous system, the endocrine system, the reproductive system, circulatory system, the digestive system, the respiratory, the lymphatic, immune, and integumentary system.
And what page is on this?
So this starts on page 88. So the body is divided into systems, planes, cavities, and basic units to give common references and terms for studying and communicating information about the body. So anatomy is a study of the structure of the body, and physiology is a study of the functions of the body. We'll talk about the structure and the functions. So the human body is made up of many body systems that are consisting of specific organs that serve specific purposes. There are 11 body systems: the skeletal, the muscular, nervous, endocrine, reproductive, circulatory, digestive, respiratory, lymphatic, immune, and integumentary. So these are all systems that work together. They all have, every body system has its own set of organs, which has its own set of specific cells and tissues. So talking about the body planes and the directions of the body is divided into 3 main planes. We can think of a plane as like a really sharp blade, if you will, that can cut the body into several pieces. So the sagittal plane divides the body into left and right. The sagittal plane can be anywhere left or right of the body. But if the body, or if the sagittal plane is in the middle, like the very center of the body, we refer to this as the mid-sagittal plane. In dentistry, we can think about this as the midline, and anything closest to the midline is the mesial surface of the tooth. The transverse plane divides the body into upper or lower sections. It's also called the horizontal plane. The front and back section is divided by the frontal plane. So this is, if you were to look at someone's profile, you could see, or you can imagine a blade kind of cutting across this way, so front to back, okay? So the front section is called the ventral or anterior, and the back section is referred to as the dorsal or posterior. So we can think of the back of the body as sort of like where a dorsal fin would go to if you're a fish or a shark. The dorsal part is the back, the front part is the ventral. All right. Who could tell me the surface of a tooth that faces the median line? What surface is that? So this would be like, if we think of the mid-sagittal plane, that's right in the center of the body. And in dentistry, we think of that mid-sagittal plane as the midline. In other words, the median line is also referred to as a midline. So what surface of the tooth is closest to the midline or median line?
Mesial.
That is the mesial, you're right. So in the whole, when we're talking about the whole body, that plane is a mid-sagittal plane. But when we're talking about just the mouth itself, we think of that mid-sagittal plane as the midline, right? Because it divides the body or divides the mouth from left to right equally. So that midline would be right in the front of these two center teeth. Anything closest to that line when we're referring to the surfaces of the teeth is the mesial surface. Good job, thank you. Okay, so now talking about body cavities. Body cavities are spaces or areas where various structures and organs are found and divided into two sections. So we have the dorsal and the ventral. The dorsal cavity contains the spinal canal, which houses the spinal cord, and the cranial cavity, which contains the brain. The anterior portion of the body, or the front part of the body, is called the ventral cavity. That contains three major parts. We have the thoracic cavity, the abdominal cavity, and the pelvic cavity. So the thoracic cavity is referred to as the chest cavity and holds the lungs and the heart, along with other accessory organs. The abdominal cavity is divided into an upper section, which is digestive tract and the supporting organs. And the lower section is called the pelvic cavity. The pelvic cavity contains the urinary bladder, the rectum, and reproductive organs. So the cell is the basic unit of all systems. So every system has a cell or its own specific type of cell. And it's also the smallest function unit of the body. Specialized groups of cells form tissues, which group together to form organs. Organs group together to form systems, and all of these systems working together create harmony in the body known as homeostasis. Homeostasis is that word that we use in the body that is everything working together exactly the way it's supposed to act. So that's the body's harmony. So this is a representation of the cell. There's different structures that make up the cell. We call these organelles, but for purposes of this class, you don't really need to know that, but these are like the separate body parts of the cell itself. So we have the cell membrane, which is the outer wall of the cell. We can think of this as like the cell skin. We have the nucleus, which is right in the middle of the cell that controls the body of the cell. We can think of this as like the cell's brain. And then the cytoplasm is the liquid fluid that all of the organelles are kind of floating in. That makes up the substance of the cell. And the chromosomes are found within the nucleus of the DNA. So the chromosomes are these little, we could think of these little squiggly lines. That's basically what makes up our DNA. These are all compacted together into like a little ball inside the nucleus. And that is where the chromosomes live, is inside the nucleus. The skeletal system serves many functions within the body. One, it provides support for the body's framework and creates the body's shape. It also aids in movement by serving as an attachment site for muscles, and it provides protection for vital organs such as the lungs, the heart, and it plays a role in the manufacturing of red blood cells. It's actually where red blood cells are made, is inside the skeletal system. It also serves as storage areas for minerals such as calcium. The skeleton is divided into two main sections. The axial skeleton is the framework of the head and trunk of the body and includes the cranium, the face, the spinal cords, the ribs, and the sternum. So that's like the main vertical section of the skeletal system. The appendicular skeleton includes the bones of the upper and lower extremities, like the arms, the hands, the legs, shoulders, and hips. The adult body has 206 bones, and a child's body has 270 bones. Bones are composed of connective tissue called osseous tissue, deposits of mineral salts, along with organic materials such as cells, blood vessels, and cartilage comprise the bone, which is surprisingly about 20% water. So a lot of our body is made up of water, and bones are no different. So here's a diagram of a type of bone. So we have different types of bone in our body. Cancellous bone consists of interconnecting meshwork of bone called trabeculae. So if you look on this bone here, the inside of this section of the bone, it's almost like sponge-like, or maybe like a honeycomb shape, if you will. Those little sponge-like areas are called trabeculae. We often see those in the gum tissue, or excuse me, in the bones, and the bone that supports the teeth in the mouth. That is that cancellous bone. These are found on the ends of long bones and in the middle of other bones. Red bone marrow fills the inside space of the cancellous bone. So where all these little spaces that we see, that is where the red bone marrow lives. Cartilage is found where the bones join. So this kind of grayish area where the bones kind of meet together, so that we don't have bone on bone. That would be very painful. So cartilage can be thought of as a type of cushion for the bone. Compact bone is a strong and hard section that forms the main shaft of the long bones and the outer area of other bones. So this is like kind of compact bone. It's not cancellous. It doesn't have trabeculae. It's just very hard and dense. The main shaft of long bones and their outer layer is made of a tough layer of fibrous tissue called periosteum. So this is this outer layer of the bone. It's very, very strong. And it's strong so that it can withstand lots of forces, especially like if we're talking about appendicular bones like legs, arms, where we need the extra strength for our appendages to do the work that they need to do. Joints are areas where two or more bones meet to form a junction. Joints or articulations are usually composed of fibrous connective tissue and cartilage. Fibrous joints are immovable and fixed, such as the sutures in the skull that are non-movable. So if we look at the skull, right, the parts of the top of the head, they're made up of plates that fuse together. So when we're children, those joints aren't really fused together. There's actually cartilage in between those plates of the head, which is why our heads are able to grow as we're growing. As we become older and as we become adults, that cartilage goes away and those joints fuse together. Now, these joints are no longer movable. They can't move. This is why our heads don't grow anymore after a certain age, or after we're done growing. Cartilaginous joints are slightly movable joints, such as the joints between the bones of the vertebrae. And synovial joints move more freely, such as in the knee and the elbow. So there are 6 types of synovial joints. We have a ball and socket, a hinge, a pivot, a gliding, a saddle, and a condyloid. So there are many conditions that commonly affect the skeletal system. So this is different pathologies, if you will. It's another word for diseases of the bones. Aging, wear and tear, and traumatic injury can all have negative effects of the skeletal system. So these are things like osteoporosis, osteomyelitis, fractures, things like that. The most common of significance to the dental assistants are a cleft palate. Okay, so this is the failure of the palate to form and join correctly. So the palate is the upper or the roof part of the mouth, right? And as we know that there's those 2 plates, just like we have plates in our head that are not formed or not fused together when we're children. That joint also is not fused together when we're children. And as we get older, it fuses together. But before we're born, it kind of fuses. It doesn't fuse, but it comes together. And what happens in the cleft palate is it doesn't come together all the way. So some babies are born with open, basically open roof of their mouth. Sometimes that can extend out to their lip, or they have cleft lip. It's a common birth defect that sometimes we have. And also the other type of dysfunction is a temporomandibular joint disorder, which is a degradation of the joint where the mandible, right, the lower jaw, articulates with the temporal bone. So basically back here where we have the jaw that comes together is a joint known as a TMJ, or a temporomandibular joint. Sometimes that bone or the cartilage around that area is deformed or doesn't work properly, and people have soreness or clicking or popping of their jaw. Okay, who can tell me what is the skeletal anatomy of particular importance in dentistry? Or what part of the skeleton are we most concerned with? Is it the arms? Is it the head, the neck, the skull?
Is it the neck?
The neck is one of them, yeah. So the ones that we're concerned with most is the cranial and facial bones, including the maxilla and mandible, but we also look at the head and neck. So any bones in the head and neck are the bones that we're concerned with. Okay, but more important is the cranial and facial bones. So the face and the head bones that include the maxilla, which is the upper jaw, and the mandible, which is the lower jaw. Okay, thank you. So there are different functions of the muscular system. The muscular system makes up about 30 to 40% of the body's total weight. The muscles contract and relax to create movements of all parts of the body, both internally and externally. So internal muscles move food, create respiration, and keep the heart beating. Muscles also produce body heat. External movement would be like our hands, our arms moving around. Those are different muscles that we use externally. There are three types of muscles. We have striated muscle, cardiac muscle, and smooth muscle. Striated muscle are made of long, thin cells that have stripes or bands across them. They are referred to as the skeletal muscles as they bunch together and attach to the skeleton. Striated muscles have the largest amount of muscle tissue and function to provide external body movement. So again, these are movements such as the arms, the wrists, the hands, our legs, and things like that. Okay, striated muscles are under voluntary control, which means we control them as we need to. And are the only groups of muscles that an individual has conscious control over, and hence referred to as voluntary muscles. Cardiac muscles are similar in appearance to striated muscles, but are involuntary muscles that are found only in the heart. The muscles are chain-like in appearance and receive approximately 75 stimuli per minute. These muscles serve to keep the heart beating in an even rhythm. So the only type of muscle that a cardiac muscle is made up of heart tissue. Smooth muscles are non-striated. They are also involuntary, and those are found in internal organs such as blood vessels, the skin, and glands. Smooth muscles are controlled by the automatic nervous system. Any questions with the muscles at all? No? Okay.
Not yet.
Stop me if I'm going too fast. So there's different characteristics of muscles. Each muscle is made up of cells in various shapes and sizes depending on its function. Cells group together to form fibers, and these fibers group together to form fibrous sheets of connective tissue called fascia. Each fiber can support about 1,000 times its own weight. So the other characteristics of muscles are the fact that they can all be excited. So they have excitability and irritability. So these are the ability of the muscle tissue to respond to stimuli. Muscles also have extensibility, which means the capacity to stretch. And then muscle tone has to deal with the tension of the muscular system. So skeletal muscles attach to the bone in various ways. Some are directly to the periosteum of the bone, or through specialized connective tissue that extends beyond the muscle. Tendons attached to the form of a cord and attached muscle to bone. So a tendon would be muscle to bone. This would be the muscle, and then the tendon would attach to one end of the bone. And then we would also have a tendon that attaches to the other bone, which enables us to move our arm back and forth. Aponeurosis is a broad flattened extension that attaches muscle to bone and muscle to muscle. Ligaments are bands of fibrous tissue that connect or support two or more bones. So here we see ligaments here that attach two bones together. So muscles contract and relax to provide movement and function in antagonistic pairs, which means that when one whole set of muscles contracts, its corresponding set relaxes. So an example of this is we have somebody's bicep here and then the tricep here. If I were to have my arm flat and I were to move it up like this, my bicep is contracting while my tricep is relaxing. So that's how that works. When I move my arm down, it's my tricep that's contracting and my bicep relaxes. So that is what an antagonistic pair is. So there's one side of the bone, or one side of the arm or the leg, whatever it is, that has to relax in order for the other part to contract. Okay. Energy in the form of oxygen and glucose is necessary for muscles to work. So when not enough oxygen is supplied to break down the glycogen properly, a buildup of lactic acid occurs. So muscles use energy in the form of glycogen, and oxygen is what breaks down that glycogen when it's no longer needed. And if there's not enough of that oxygen that gets into the muscles to break down that glycogen turns into lactic acid. That's how we get our muscles that get sore after a while. It's just a buildup of lactic acid that happens inside of them. And so it takes a while for our muscles to kind of build up that oxygen again and to repair itself so that it can stop hurting. So there's different muscular system diseases. These are conditions and diseases like strains, sprains, cramps, and inflammation. Those are just some common muscular conditions. Sometimes more serious injuries and diseases occur. A spasm is a sudden involuntary muscle contraction. Atrophy refers to the deterioration of muscles when they aren't used sufficiently. So this is the shrinking of muscles. Fibromyalgia is a chronic pain in the muscles and soft tissues surrounding their joints. The congenital disorder characterized by progressive degeneration of skeletal muscles is called muscular dystrophy. Myasthenia gravis is an autoimmune disorder that leaves muscles weak and fatigued. All right, who can tell me which muscles are of significant importance to the dental assistant personally when on the job? What muscles do we use when we're on the job?
The striated muscle. Oh, wait. Yeah.
Yeah, probably the striated muscles, right?
Yeah.
Um,
I'm like, am I looking? I'm looking right at it.
right, because
That's
striated
literally-
muscles are the ones that we use to move appendages around. So we definitely need our arms, we need our hands. Of course, we use our hands a lot in dentistry. What other muscles do we use on the job?
Antagonistic pairs. That's the muscle function.
So we definitely use antagonistic pairs. But another thing is muscles of the lower back and neck, right? Because we're usually hunched over, all kinds of weird different positions. We definitely use our neck and our back. This question is kind of a little strange because we actually use all of them. We actually need to live and breathe in order to do our job. So we definitely use our cardiac muscles, and we definitely use our, what is the other muscle system? We have our striated, our cardiac, and what is the other one?
Is it the smooth muscle tissue?
Smooth muscle tissue. We need our blood vessels to live, right? We need our digestion to work properly in order for us to be alive. So we actually use all of them, but there's definitely the muscles of the lower back and neck that we use a lot, on top of our hands and our fingers and our arms. So thank you for that. Good job. All right, so now talking about the functions of the nervous system. So the nervous system functions to transmit stimuli from outside and inside the body, with the ability to respond and transmit stimuli in order to retain unity and harmony in the body. So they serve as the body's communication system, and they maintain the body's unity and harmony through response and transmitting. So this is how the body stays in homeostasis. All of these different systems, or these body systems, work independently, but they also have to work together in order to create that homeostasis. And the nervous system is what connects all of them together. So, structures of the nervous system. The brain, the spinal cord, and the nerve cells are the three sections of the nervous system. The central nervous system, or the CNS, contains the brain and the spinal cord. The brain receives, interprets, and processes the information. The spinal cord transmits stimuli from the body to the brain. The nerve cells carry messages to the muscles and organs within the body. All of the nerves outside of the CNS make up the peripheral nervous system, or the PNS. The autonomic nervous system, or the ANS, is composed of a specialized group of nerves that function automatically. So this is basically what a typical nerve cell looks like. A nerve cell is also called a neuron. So we have the dendrites, which are these little like nerve-like, or they almost look like electricity-like projections of the nerve. This nerve cell also has a nucleus. Most cells have a nucleus. We have the axons, and then we have the beads of myelin. These are also known as myelin sheaths. And so we have all of these nerves are connected together like in like a almost like a single file form. So we would have these dendrites here so these are dendrites. This axon actually ends out here. So this area here is also known as the axon. These dendrites will be connected to the next nerve's axon. So they kind of go one after the other. Okay, and none of these nerves are connected physically together. Instead, there's an area right in between the axon and the dendrites. So the axon kind of meets the dendrites. There's an empty space in between each one of these little tentacles. This is called the nerve synapse, and this is where the nerves are connected via chemicals. So we have like, for example, we have adrenaline that one nerve kind of pushes out in the synapse, and the other one kind of catches that whatever chemical that is, and it sends it like an electronic signal throughout all of the different neurons that are connected together, and it does it very, very quickly. So this is why when we touch something, we touch heat, for example, it's very hot. This acts so fast that sometimes our body will actually it'll respond to that stimulus before we even realize what it is. So if we touch something really hot, our body will automatically, like muscles will make sure our hands are no longer touching that hot surface before we even realize that that surface is hot. So it acts very, very quickly. So the main part of the nervous system is the spinal cord. It acts as a center of reflex, which is involuntary responses, and transmits stimuli from the body to the brain. Reflexes occur when a stimuli is sent through a neuron into the spinal cord and a response is sent via the motor neurons. So this is what I was talking about before. If you touch something, that reflex happens before you even realize, oh shoot, I better move my hand because this is very, very hot and it's burning me. No, there's a reflex that happens before you even have a chance to think about that. So there are 31 pairs of spinal nerves. They are named and numbered according to the closest vertebrae. The brain receives incoming stimuli, interprets and processes the information, and directs them to various sections to create a response. There are 12 pairs of cranial nerves, which are numbered with Roman numerals connecting in the front of the brain. Thankfully, we don't have to learn all of these pairs of cranial nerves. I had to before. It's not fun. But there's a lot of different cranial nerves inside the brain that make up the part of the CNS. Neuritis is a type of nervous system disease that we'll talk about. This results from a fall or blow resulting in inflammation of the nerves. Multiple sclerosis, or MS, usually occurs between the ages of 20 and 40. So that's a degenerative disease that destroys the myelin sheath. Remember, the myelin sheath is these beads of myelin here. So that destroys the myelin sheath of the neurons in the CNS. And as a result, impulses cannot be transmitted. The chronic nervous disease characterized by the body slowly spreading tremors, muscular weakness, and a peculiar gait is called Parkinson's disease. And Bell's palsy is a sudden onset of facial paralysis. So these are all diseases of the nervous system. Okay, who can tell me what types of procedures require the dental assistant to have knowledge of the nervous system?
Root canal procedure?
Yes, the root canal procedure. Let's see. On top of the root canal procedure, because the root canal is a type of nerve, right? So it's the administration of anesthesia and surgery. Why is this part of procedures that the dental assistant has to have knowledge about? Do you guys like my house, by the way, my new house? It's nice, right?
Yeah.
I wish, but anyway. So this is not really a trick question. This is just because of the fact that when we're administering anesthesia and surgery, what are we dealing with? The deadening of what?
Of nerves?
The deadening
Right?
of nerves, right, exactly. So we don't actually kill the nerves, but we cause them to go to sleep, right? And so knowing how nerves work kind of gives us a little bit of background knowledge on why anesthesia works. Good, thank you for that. So the endocrine system is a controlling and communicating system, much like the nervous system, but it reacts slower, yet its results are longer lasting. So the endocrine system functions to control growth, protect us from stress, stimulate the sexual drive. It regulates calcium and water balance, and also produces insulin, which aids in the transport of glucose. So the endocrine system is basically the system of all the hormones in our body. Another thing that it does is it controls growth. Oh, we said that already. Okay, I didn't say these things here. So the first part of it was it protects the body from stressful situations by releasing the flight hormone, which is adrenaline. Promotes sexual development and regulates water balance and the use of calcium. Insulin is a natural chemical or natural hormone that our body produces. It's produced by the pancreas, and it's basically like a lock and key system, which allows glucose to enter the cell. Without insulin, glucose cannot enter the cell, which is basically what the main energy source for our cells that get used. So people that have diabetes, for example, either can't produce enough insulin on their own, or their body no longer produces insulin at all. Okay, so hormones control the internal environment of body from the cellular to the organ level. So these are similar to like a thermostat in your house. So the endocrine system is made up of glands, which are grouped according to structure and interrelated functions throughout the body. The glands produce secretions called hormones, which empty directly into the bloodstream and circulate throughout the body. Okay, so these are dental concerns related to the reproductive system. So the main function of male and female reproduction system is the creation of new life, right? So in both sexes, primary and accessory reproductive organs must be protected. This is why we use lead aprons when we're exposing radiographs, because those are very radiosensitive organs or radiosensitive tissues and cells. Also, adequate ventilation during nitrous oxide is important. That's because especially during the first trimester of a woman's pregnancy is when all of the different organs especially the really important parts of the organs hang on. Somebody calling me. Okay, sorry. This is when all those organs are being developed. And so during the first trimester is where the most volatile stage is. It's where the CNS is being developed and things like that. And nitrous oxide sedation, or any type of nitrous oxide that a pregnant woman breathes in, can actually put that woman into premature labor. So this isn't as threatening or life-threatening to the baby if we're in the third trimester, right? Or there's even survivability in the second trimester, not in the first trimester. We definitely don't want a woman to go into premature labor during the first trimester. That would be really bad. Okay, so these are glands of the endocrine system. Okay, so the pituitary gland is the master gland that releases hormones that affect how other glands work. The thyroid increases the metabolic rate. The parathyroid regulates the level of calcium. The adrenal releases the flight or fight hormone, also increases the heart and blood pressure and aids in metabolism. The pancreas produces hormones such as insulin and glucagon. The testes are responsible for the male sexual development, and the ovaries are responsible for the development of female sexual characteristics. So there are diseases and conditions of the endocrine system. Diabetes mellitus occurs when the pancreas produces an insufficient amount of insulin. Hypothyroidism is a result of an underactive thyroid, and hyperthyroidism occurs when the thyroid is overreactive. Obviously, pregnancy is not a disease, but it is a condition, right? So that is one part of a condition of the endocrine system. The circulatory system maintains a balance between intercellular and extracellular fluids. So a continuous supply of oxygen, nutrients, hormones, and antibodies are transported throughout the body while wastes and carbon dioxide are removed. The heart is a triangular shaped muscle the size of about a closed fist that circulates blood throughout the body. There are three layers that cover the heart. The pericardium is the outer layer composed of a double-walled sac. The myocardium is a tough muscular wall, and the endocardium is a thin lining inside of the heart. There is a wall that divides the heart into right and left valves, which are each divided into two chambers. The upper chambers are called the atria or auricles, and the lower chambers are called the ventricles. So here is our diagram of the heart. Okay, so these are the different chambers that we're talking about. This atrium here, or the septum, is like kind of like a wall that divides the two atria. So we have our left atrium and our right atrium, and then each atrium is divided into two sections. We have our ventricles, and then our atrium is on top. So there are different valves in the heart that we need to know about. The tricuspid valve is here, and this is the valve that connects the atrium to the ventricle. Our mitral valve is also known as our bicuspid valve, and this is the valve on our left atrium that connects the left atrium to the left ventricle. Okay, our aortic, this is our aorta. This is the main artery that goes into the heart. So it goes into the heart and out into the rest of the body. So the vessels carrying oxygenated blood from the heart to the capillaries is called the artery. Okay, this is the vessels that carry oxygenated blood. The walls of the arteries are composed of three layers to withstand pressure. Arteries range in size from the aorta, which is the largest artery. This is the one that comes directly out of the heart, to the arterioles, which is the smallest arteries. These are the arteries inside of the lungs, or pulmonary arteries. Veins are also composed of three layers, but are much thinner and less muscular than arteries. Blood carrying wastes and carbon dioxide is transported from the capillaries back to the heart via veins. So these are like a lower pressure type of blood vessel. The aorta is a higher pressure type of vessel that comes directly from the heart or directly from the lungs, depending on if it's going to be oxygenated or not. And the veins are the lower pressure vessels. So blood serves a number of purposes. Okay, it transports nutrients, gases, wastes, and hormones throughout the body. Body fluids are regulated, pH and body temperature are regulated, and blood protects the body from pathogens. And blood loss after injury. The average person has about 4 to 6 layers of blood circulating throughout the body. The liquid portion of the blood is called plasma and is made up of about 91% water, so mostly water. It carries nutrients, hormones, and wastes. The solid part of the blood is called corpuscles, of which there are 3 types. We have erythrocytes, which are the red blood cells. Those contain hemoglobin, which is a protein that allows them to carry oxygen. And then there are leukocytes, which are the white blood cells. There are 5 types of leukocytes that protect the body from disease. Thrombocytes are platelets, which are little tiny fragments of cells that are required to make the blood clot. So erythrocytes, again, are the red blood cells. Leukocytes are the white blood cells. And thrombocytes are the platelets that allows the blood to clot. Okay, there are different blood groups. 5 blood groups are A, AB, B, O, and ABO. For the purposes of this class, we don't need to go into what makes a person have a different type of blood type. Just know that there are 5 types of blood groups and what they are. There's A, AB, B, O, and ABO. Pulmonary circulation is the circulation of blood through the heart and back to the heart. Systemic circulation carries the blood from the aorta to the smallest blood vessels and back to the heart. Bacterial endocarditis is an inflammation of the heart lining. So we're talking about circulatory system diseases. Hemophilia is a disorder in which the blood fails to clot. And leukemia is a malignant progressive disease of blood forming organs. So it's a type of blood cancer. All right, who can tell me why the dental assistant must be alert to cardiovascular emergencies in the dental office? Any ideas, any guesses?
Because we're giving them anesthesia, and they also could have a heart attack if they have anxiety.
Yes, exactly. So for many patients, a visit to the dentist is stressful. A person with some type of heart disease or cardiovascular disorder is at an increased risk for a cardiovascular emergency, especially when stressed, when sedated, or when we're giving them anesthetic, especially with the anesthetic with what in it? What do our anesthetics have in it that is a vasoconstrictor? From dental pharmacology, what is the most common vasoconstrictor that we use?
Is it epinephrine?
Yes, it's epinephrine. And epinephrine is a type of what?
A stimulant?
A stimulant. It's actually adrenaline or natural adrenaline. We produce epinephrine in the body naturally. And it's an adrenaline that actually helps the heart to have that fight or flight response or get going when it needs to. So somebody that has a cardiovascular disease, has high blood pressure, has some other heart disease that is not good if it gets stressed, and we're using anesthetics, right? We accidentally put some of that epinephrine into their bloodstream, what can happen? What happens when the heart gets stressed? A type of cardiovascular. They can have a heart attack, exactly. We do not want the heart to stop or to have any type of infarction or anything like that when they're in the dental chair. That's just bad publicity, so we don't want that at all. All right, so digestion or the function of the digestive system. Digestion works or involves breaking down nutrients, transferring them into the blood system to be absorbed by all the cells of the body and eliminating body waste. So that is the function of the digestive system. The alimentary canal, or these are the structures of the digestive system. The alimentary canal is a tube from the mouth to the anus and includes the mouth, the pharynx, the esophagus, the stomach, the small intestine, the duodenum, and the large intestine. Some accessory organs are the teeth, the tongue, the salivary glands, the liver, the gallbladder, and the pancreas. So these are all structures of the digestive system. So there's different diseases and conditions of the digestive system. The destruction of the tooth surface is called tooth decay, and inflammation and deterioration of the periodontium is called periodontal disease. Bulimia is an eating disorder with which an individual vomits after consuming large amounts of food. Hepatitis is an inflammation of the liver caused by 3 main hepatitis viruses. And then these are the function of the respiratory system is to supply the body with oxygen through inhalation and eliminates carbon dioxide through exhalation. Air is inhaled through the nose and the mouth and brought into the lungs, where it is absorbed into the bloodstream and carried to all the body parts. So there are different structures of the respiratory system. The respiratory system is made up of the nose, the pharynx, the larynx, the trachea, the bronchi, which are inside of the lungs, and then of course the lungs themselves. There are diseases of the respiratory system. Asthma is the muscular spasm of the walls of the bronchi, leaving the airway constricted and making exhalation difficult. Tuberculosis is a highly contagious disease of the respiratory system. Lung cancer is a malignancy of the lung tissue. A cold is known as rhinitis. It's also obviously an infectious disease. Pneumonia is inflammation of or it's actually water or fluid inside of the lungs. And bronchitis is inflammation of the bronchial tubes. All right, for the respiratory system, who can tell me the use of what in a dental office may be contraindicated in a patient with respiratory disease? Think of a type of sedation that we use. What type of sedation do we use in the dental office that requires the person to breathe?
Nitrous oxide.
Very good, nitrous oxide. So if a person has some type of respiratory issue, like any of these things here, if they have a cold, they have asthma, hopefully they don't have tuberculosis up in our dental office, but if they also have bronchitis or anything like that, they should not be using nitrous oxide because they have breathing problems as it is. And nitrous oxide requires them to have full breathing capacities, especially through the nose. And as we know, for any of us that had a cold, our nose isn't something that necessarily works very well. So those are some of the things that we need to know. Okay, good, thank you. So we're going to talk about now the functions of the lymphatic system. The lymphatic system is a network of vessels that drains and filters tissue that surrounds the cells. There's different structures of the lymphatic system. Tissue fluid is called lymph. It's a clear fluid that is transported through the lymphatic capillaries. Lymph nodes are located in groups along lymphatic vessels. They filter blood and manufacture antibodies. The spleen is the largest lymphatic organ. It removes bacteria, foreign bodies, old red blood cells, and acts as a storage for blood. The thymus is located underneath the sternum and is important in the development of the immune system. Tonsils guard against bacteria entering the body through the digestive and respiratory tracts. And then the immune system protects the body from pathogens, foreign materials, debris, and damaged cells. Non-specific immunity refers to the body's defense against harmful agents. Specific immunity acts against selected agents. So these are some of the lymphatic and immune system diseases. Tonsillitis is a chronic infection of the tonsil tissue. Hodgkin disease is a malignant disorder that causes the lymph nodes to enlarge. An allergy is a hypersensitivity to a certain substance. And then immune deficiency disease is a failure in some part of the immune system. Okay, next we're talking about the integumentary system. This deals with protection, temperature regulation, metabolic regulation, prevention of water loss, and the synthesis of vitamin D for where we actually make vitamin D. So these are giving you clues as to what this is. The integumentary system is basically our skin. Okay, so it also produces melatonin, produces keratinocytes. It stores water, fat, and vitamin D, and also aids in wound healing. So the structures of the integumentary system are the skin, which includes the epidermis, the dermis, and the subcutaneous or the hypodermis. So the epidermis is the outer layer of our skin, the dermis is the inside layer of our skin, and the subcutaneous or hypodermis is the very lower levels of the skin right before we get to the muscle. Okay, we're also talking about nails and hair. Those are all part of the integumentary system. So we can have some conditions of the skin. We can have abnormal skin coloration. These are things like albinism, where somebody does not produce any melanin, so their skin is completely white. Cyanosis is when the skin becomes blue because of lack of oxygen. So if somebody is cyanotic in the chair, that means that they are suffocating somehow. Erythema is like a redness in the skin, sort of like an inflammation. Hematoma is basically a bruise. Jaundice is when we have yellowing skin color because of there's something wrong with the liver. And then pallor is like a flushing color where there is no blood getting to that to the skin, causes the skin to become very pale. Integumentary system diseases are diseases and conditions are carcinoma. It's a type of skin cancer. Malignant melanoma is another type of skin cancer. Dermatitis is like a inflammation of the skin, usually like some type of allergic reaction. Acne is of course like pimples and things like that. Cellulitis is like how like somebody that has cellulitis is somebody where there's like this, the skin is like dimply or patchy because of the abnormal deposition of fat. And then there's warts, which is a type of human papillomavirus. All right, what abnormalities related to the integumentary system should the dental assistant take note of and report to the dentist?
I mean, cyanosis, but I mean, I feel like that's.
I would think cyanosis, right? Right. So this is a type of discoloration. If we see a blue patient in our chair, there is something definitely wrong with them. So we need to alert the office, or excuse me, alert the dentist right away. So that's number one. Also, any lesions, sores, or rashes. That's because these are signs of some type of reaction. If they have a lesion, they could have some type of communicable disease that the dentist should know about. Sores are the same thing. Any rashes can be signs that they're allergic to something in the office. So these are things that we need to look for and report to the dentist if we see them. So as dental assistants, we're the dentist's eyes and ears. So obviously we can't do some of the things that the dentist can do, but we are basically who the dentist counts on to be their second person. So if we see these type of things, we need to report it to the dentist right away. Okay, that was exactly 1 hour. Not bad, right? So that's all that I have for chapter 6. Chapter 6 was a lot of information to be wrapped up in one whole chapter. Like this can be like an entire semester's worth of class in a normal college campus. So it's a lot of information. The chapter itself is a lot of reading to do. So if you haven't already read the chapter, I advise you to do that now. And then also start getting to work on some of the things that you need to be working on, which are here, let me stop that screen share, which are, of course, your portfolio projects, and always be working on your study guide. As you go through these chapters, and if you see information that you kind of recognize on your study guide, go ahead and start filling that out so that you're not left with this huge document to try to fill out right before the final. Okay. Anybody have any questions before we break for a long 4-day weekend? Yes, Lolly.
Where are we supposed to turn in the vocabulary? Because there's no like red folder for it.
The vocabulary. Let's look at that now.
Yeah.
Let me just open up that page really quick. Because I don't know, I mean, I remember putting it together, but knowing me, I might have forgotten to unlock it. It is. Ooh, hidden from students. Okay, well, that's not good. Let's make that available. Okay, now you should see it. So this is the vocabulary definitions assignment week 5. And let me go ahead and make it red so it doesn't throw anybody else off. Okay, it should be there now. It's vocabulary definitions assignment week 5.
Thank you.
Thank you for that. I appreciate it. All right, any other questions with anything at all or anything that's due tonight? Okay, I have not finished grading everything yet for Den 130, so give me about till I would say by the end of the day tomorrow, I should have everything in and I should have grades finished out for us. Grades will be posted no later than Saturday night at the latest. So if you see anything like Friday night or like early Saturday morning and something doesn't seem right, by all means, please reach out to me so we can get it figured out before I post grades. Okay, any other questions at all? Awesome. All right, well, you all have a very safe Memorial Day weekend. Don't get too crazy. And I will see you back again on Tuesday. We will have a Zoom call on Tuesday, so please look out for that in your announcements. All right, I will see you later. Thank you.
Bye. Thank you.
Bye.
Bye, thank you.
Bye.